You're looking at video 31. I know my first video was a little bit, I said 29 and it was really 30 by accident. And you know, you get into these numbers and that, it can happen. Anyhow, here's some voltmeters I got. These are set at alternating current. There's on the 20 there, set at alternating current, 20 there. This is direct current because it's hooked up right here. This is 20 on. This is direct current. So this is direct current, and these two are alternating currents. You can see the meters all real nice and clear. I hooked them up underneath here. You can see the wires going to there. I put these little clips on there. Right there's the coil. Got a little close on that TV. Anyhow, you can see how that does. This is the coil here that I was trying out earlier. I just wasn't getting that much. I had this inside there, and I yanked it off there, and I put the wires on it and that. That's the reason why these wires are hanging down. I yanked them off. This is from the last test. It was that thing, and still maybe have a little bit of juice in it. See if it does. No, there's no juice left in it. Anyhow, this is the three lights that you were seeing in video 30. And that. I just yanked the wires off of that. Basically, it's a wound coil like this with two of them in there on that flashlight. Right there it is. You can see it down inside there. What I'm going to show you is inputs and outputs like I promised. Let me start this off here. And I'm going to hit the switch right here for this meter here. As you can see, I'm putting about 5.5 volts into it, and approximately 2 amps. The outputs here are 10 on the 1 meter, roughly 10 volts, and on the other meter, roughly 9. So putting 5 in, and getting these two out from the coil, those wires right there, oscillating down inside that coil. Faraday's law. I'm going to show you something here. This is the first frequency that we're talking about. As you notice, look how slow that thing is turning. I mean, it is turning super slow. Thing is about, if you know anything about generators, I don't think you can really turn it that slow with that small amount of energy and hardly get anything out of it. It's a new patented type of technology I have. Let me show you something here. I'll start putting some more juice into this thing. Try to get out of the light here. Put this off the side here. As you can see it, I'm going to crank this up. I'm going to switch this over to from 6 volts here, 12 volts. As you can see, I'm putting this much in, and these meters are reading a lot more. Let me read it. And if I adjust it slower, see how much it comes back down. 720. These meters are showing that. I speed it up. Matter of fact, I can put this at full throttle. I'm getting almost 15 This one's 12.87. We're not even putting 12 volts in, and I'm getting these out of it. You can see that's 15 over 15 volts. Just a little over 12. You can see it's oscillating in there at pretty good speed. It's moving. I've only got that's only one lever arm that I'm running. Let me recap on that. But maybe you can't hear it. That is only one lever arm running right here. Right down inside here. Making that. Ideal is, as this thing keeps going, it trips these and keeps these things going. It just doesn't take that much off of there. It was only 2 amps over here being drawn when it was running. 2 amps, and it was only running here, maybe it was 3. Let me double check that again. About 3. So about 3.5. Right there you're getting about a little less than 12 volts that's coming off of here. You got this with the wires hooked up. You got 15.2 and you got 12.69. Switch it down. Gotta okay, here I'm putting in 2. I'm feeding in, there's about 5.5 volts right there. I got it hooked up. There's these hooked up. I'm pushing almost 11, and this one's done. You see more variations on it because it's running so much slower. It's oscillating there. That's why I'll speed it up now. Actually, it's shaking a little bit if you watch it. If you come back up, because you see how steady that stays? Once that's the higher speed. In case you couldn't hear me, if you notice, we'll let this quiet down. I don't want as much noise. If you notice, as I picked it up on the higher speeds, these meters were more steady. The other ones, when it was at the lower speeds, there was a lot of fluctuating in that, if you notice that. Right now, you're going to ask me about amps. Right now, I'm trying to figure out how to do this properly. Some people say that you got to have a load for amps and that. Even this battery right here, I'll show you, it's like 6 volts. It's DC as well. I'll put this clip on here and put this clip on here. .36. The thing is, if you hook this battery up to it, it'll draw it. It won't keep it steady, where a transformer will. I mean, it's not a very steady source. But I'm just showing you, and it's a new battery. That's just why it's 3.36. I mean, if I put this on here and that, it'd draw it down to 5 volts real quick and that. I mean, there's no problem. What I had going on earlier was there was a blown bearing down inside here on this particular lever arm. I put a new bearing in it. It was making the voltage go crazy. I couldn't figure out what was going on. A lot of times it's a prototype, things happen. You know, of all things, you know, when you're working on this thing, you're not going to be thinking about a blown bearing down inside there and that. Anyhow, this is the motor here that he's feeding the power in. It's nothing special. Buy them at Radio Shack. All it is just a water pump thing that pumps water. You know, nothing special catalog or whatever. I liked it because it didn't show much voltage to run it at. It could run on variations. Even the little motors in that would eat a lot of voltage up. I'm just trying to prove this thing called quantum mechanics. It's what I'm trying to get into right now. That's the whole idea of this thing, is trying to prove quantum mechanics, but you know, I've showed you that. Could you imagine that when I get these other coils in here? I'm going to put those in too. I mean, relax. I only got one put in. I just wanted to show you that I put in one coil. What slowed me down, like I said, was the blown bearing down inside here. There was a bearing inside of here. There's like a couple, and then they all come across inside of. There's bearings all through this thing, everywhere. I had one blown bearing. It was causing the meter to go crazy, and I couldn't figure it out. Had me going nuts for a little while. Had to tear it all down and see what it was. Why that lever arm wasn't working properly in that. And all it was a blown bearing. And sometimes you get that, you know. But it seems like it's running pretty good. I got to tear this down. This is a little bit too close inside of here. I'm going to have to tear it all back down to this point. I can pull this off of here and this off of here. This unit here, I'm going to re-tear that down and redo it too eventually. And I want to get it so I can lift each section off. I want to lift, you know, if something happens in this here, I could yank that whole section off and leave all the others you know, intact. But hey, right now there's just way too much magnetism in the fields and stuff. It's way too strong. And what I learned from this unit, I'm going to incorporate into this unit. This will have a total of 32 coils. So you could imagine where I'm going to get, I won't need these up here, these parts and stuff, and I'll have to try to get it together. I got a new gear on the order. It's similar to this gear, so I could have two separate prototypes. I'm not going to rob them back and forth. It doesn't make sense in that. So that's where I'm at on this thing. It's come along. At least I showed you some volts. I'm going to try and get some amperage readings and that. I got like a little meter over here. I think this particular one, it's got some other things on it that maybe I could read some amps. It checks batteries and stuff for what's going on, which this one doesn't have those options on it. It's just, but I bought it because they were inexpensive. And they had nice big readouts where you could see stuff in that. And then that other one's got like a little readout. Here's an extra meter in case. I might have blown a fuse in them. I don't know what's going on. I just can't seem to get the amps to read properly. And, you know, maybe it's probably has to do with something with the load or something. And that's what I'm trying to figure out at this point. But as you can see, this thing, I can pull this back off of here. And it goes right back to 0. I put it back on here. You know, I'm just trying to be as honest as I can with you. I mean, I'm not trying to pull any things in that. I mean, you know, and another thing is, you know, scam artists aren't going to get anywhere. I mean, they're just going to get people mad at them. They look at their videos and they're not going to be nothing. So I'm really working with that. Like I said, I took the voltage off of here. You could see it here. You could see it there, what I was putting into it. And you could see just the output voltage here. I'm going to try and get the amps together. Everybody wants to know. It's up there. A coil like this will put out more amps because of the thick wire. I mean, I'm sorry, this one right here. This one right here. See how thick that wire is and how thin those wires are down there. But this, I figured out how to wrap it. It doesn't put out a whole lot of voltage, but because it's a thicker wire, it's going to crank out the amps. So what I was thinking is maybe I could just you know, try to hook that up into it and try to get it going. I'll let you go. Bye.